Hello viewers, in today's session we are going to discuss some important problems related to Dirac delta function, right? So here we are going to discuss those problems which are based on the derivatives of Dirac delta function. So let us start. So let us first take this problem in which we have to evaluate this integral which is from minus infinity to infinity e raised to minus x square, and here we have the first derivative of Dirac delta function, that is delta prime of x minus 1, right? So in this lecture we'll see how we can find out the values of these kind of integrals which involves the derivatives of the delta function, right? So let us first see the property which we are going to use to solve these type of problems. So here's here we know that if we have an integral say from minus infinity to infinity, here we have a function f of x, and here we have the nth derivative of Dirac delta function, that is delta n x minus a dx. Then the value of this integral is given by minus 1 raised to n, and we have here the nth derivative of this function f of x evaluated at this point, that is a, right? So this is an important property of delta function, in which we have to find out the integral from minus infinity to infinity f of x, and here we have the nth derivative of the delta function, right? So n denotes the order of the derivative, order of derivative of delta function, right? So the value of this integral is given by minus 1 raised to n, and here we have the nth derivative of this function evaluated at this point, that is x is equal to a, right? So we'll use this property. So let us come to this problem. So here if we compare this integral with this one, then we see that our function f of x is e raised to minus x square, and here we have delta prime. It means the value of n is 1. So the first derivative of delta function is involved, and here x minus a, so here we have x minus 1, so the value of a is equal to 1. So now since n is equal to 1, so it means we have to find out the first derivative of f of x, right? Because here we have n is equal to 1. So f prime of x is given by the derivative of e raised to minus x square, and we have here e raised to minus x square, because the derivative of e raised to minus x square is e raised to minus x square, and then by chain rule we have to find the derivative of minus x square. So we have e raised to minus x square, and here we have minus 2x, right? So this is minus 2x e raised to minus x square. So the f prime of x is given by this expression. Now let us find out the value of this derivative at this point, that is a, which is f prime of 1. So we can substitute x is equal to 1 in this expression. So we have minus 2, then we have 1, then we have e raised to minus 1 square. So this is minus 2 times e raised to minus 1, that is minus 2 over e, right? So now the value of this integral, let us call this integral as I. So the value of this integral I can be written with the help of this expression. We have minus 1 raised to n. N is 1. So here we have 1. Then we have f prime of 1, right? So minus 1 raised to 1 is simply minus 1, and f prime of 1 is given by minus 2 over e. So here minus 1 multiplied with minus 2 is plus 2, and it is divided by e, right? So the value of this integral is given by 2 over e, where e is the exponential number, right? And here remember, e raised to minus x square is a Gaussian function. So now let us consider this problem. So here we have minus infinity to infinity, and we have x times the second derivative of delta function x plus 1 dx, right? So here we have to evaluate this integral with the help of this result, right? So let us compare this integral with this one. So our f of x is given by x, right? And here the second derivative is involved, so the value of n is 2, and here we have x plus 1, right? And here we have x minus 1. So x plus 1 can be written as x minus minus 1. So our a is equal to minus 1, right? Okay, so now see, the value of this integral I is given by this expression. So we have minus 1 raised to 2, because the value of n is 2, and then we have f double prime of a. So a is our minus 1, right? So minus 1 square is simply plus 1, and here we have f double prime evaluated at minus 1. So 1 times this number is given by f double prime minus 1, right? So now we have to find the value of this expression. So here we have f of x. So the first derivative is given by d by dx of x. So the derivative of x with respect to x is 1, and the second derivative is given by d by dx of 1, right? Because here we have 1, and this is a constant, and we know that the derivative of a constant is 0, right? So the value of the second derivative f double prime of x at this point, that is minus 1, is simply given by 0, because this term is independent of x, right? So we have the second derivative at minus 1 is equal to 0. So here we have simply 0, right? So the value of this integral I is equal to 0.